Hi, everybody. Well, these are good, bright lights. I can't see anything at all, so that's promising. Hi, I'm Jason. I work as a developer avocado or advocate, depending on how you pronounce it, at Gatsby. I formerly worked at IBM. If you were here last year, you may have seen me talking about IBM things. And I currently live in Portland, Oregon. And I'm here to make a sweeping proclamation with absolutely no hyperbole about how apps should be in production. You should use GraphQL for absolutely everything. And you should serve your entire app as static assets. And any other solution is incredibly and completely wrong. I'm kidding, kind of. And the reason I say that is because development today is different than it used to be. Who here remembers developing like WordPress sites or movable type sites or Drupal or Magento, things like that? Anybody still doing that? Couple hands. So the monolithic CMS used to own everything. But now monolithic CMS solutions are starting to die. And I don't mean that they're dying like they're ceasing to be used. I mean that they're shifting. They're changing. They're becoming something different. And today, instead of one monolithic CMS solution that you need to get all of your data in, whether or not the CMS was built to handle that kind of data, now we have this idea of headless CMSs. Even though the classic monolithic CMSs are starting to move this way. You're seeing WordPress as a headless CMS. You're seeing Magento, they either have or are working toward a headless solution. You're seeing a whole suite of new content management systems that are strictly designed to be headless. Things like Contentful, things like, I don't know. Now that I'm trying to think of some, I'm going to forget them all, but I promise they exist. And the trend is really clear here. Like, things are going headless. And what this means is that we're moving to something new. We're moving to something that we've been calling the content mesh at Gatsby. And what we mean by a content mesh is that websites are no longer all coming from the same place. So if you look at a website like this, if you were doing this in, say, WordPress, what you would end up doing is you would have your WordPress site. You would upload some assets and some text. That's what WordPress is good at. It's good at managing assets, content. But then you need to put some items for sale. So you have to hammer some plugin solution that hacks around WordPress's content management system to make it work for commerce. And then you need search. So you have to hack some plugin solution into WordPress to make search work well. And that's not ideal. So today, what happens is we just use different services for the things that they're uniquely good at. We pull in search from Algolia, because Algolia is uniquely good at search. We pull in assets from Cloudinary, because Cloudinary is uniquely good at managing assets. We pull in content from Contentful, because that's what it's built to do. We pull in our commerce stuff from Stripe or Shopify, because that's what it's built to do. We're using the tools for the thing that they're supposed to be used for. We're not being forced to choose the thing that's closest to our needs and then shoehorn everything else into it. This is a huge shift in the way that we make websites, and it's absolutely amazing, because it gives us power we never had before. We can now take our data and manage it in the place that makes sense to manage it. If you find that you have a bunch of tabular data, put it into Airtable. You don't have to figure out a way to manage tabular data in Magento or in whatever your CMS solution is. You can just use the thing that's great at it. But you don't have to use Airtable for everything. You can combine different services. We can load our data from anywhere using these APIs. These headless services allow us to pull this data in from everywhere. And that means that we can build custom UIs that combine multiple data sources. We can pull in our data from 100 places if we want to. That is incredibly powerful. This has been popularized as the Jamstack, if you've been looking at this space. JavaScript, APIs, and Markdown. It allows you to build a completely static site using data from all over the place. It's really, really powerful. It's also terrible. And what's terrible about it is that there are atrocious performance pitfalls when you start loading 100 APIs in one UI. How many people have done that? How many people made it super fast? How many people made it super fast with less than 6 weeks of dev effort? I don't think I see any hands. It's really bright up there, so I can't see it. It also gives complex business logic that typically gets put into the UI. Now we're combining data from multiple places. You need your Shopify orders, and you need some Stripe data to process like refunds and payments, and then you want to also pull in some CMS stuff, maybe some analytics things. You got to plug that into search. We shouldn't be managing all of that in our UIs. That's kind of messy. And on top of that, our UIs end up being really tightly coupled with the backends that we're building. That's a big problem. We don't want that. This leads to things like tons of requests being sent, things like you're bound to your slowest request if you don't build properly. You have content reflows, you've got jank, the flash of unsized content, your fonts are flashing in and out. Lots and lots of problems here. And also, you end up with front-end teams managing full stack apps. Front-end teams shouldn't be building the business logic, the back-end or data tier for apps. They're front-end teams, let them build front ends. So this is not necessarily the best way forward. Then we get into things like state management. Now, who here has worked on, say, like a Redux instance that is managed by more than, I don't know, 5 teams? Any hands? I worked on one of those at IBM. And I'll tell you what, no one knew what was going on. So every single new thing that happened in that React app was a new action in Redux. Whether or not it already existed, we just didn't even bother trying to understand what other people were doing because our state management was so out of control. And then just beyond that, like, this is what we see with the content mesh. This is the loading screen. I didn't scroll, I didn't speed this up. This is just what it looks like to load a page on a lot of news sites. You have content for a second, it jumps around, something pops in, something else pops in, the ad network finally loads, so it pops again, and then finally, after 5-6 seconds, you can start reading the thing that you came to read. If you're on a slow network, this will happen for 10, 15, 20 seconds, and it makes it completely unusable. Who here has like rage quit most of the top 10 lists that they've seen on social media? That's me every time. I just don't even click them anymore because they're so hard to use. The websites are so janky. So how do we do this? How do we tame this content mesh? What is our solution to making this actually work? We've got this incredible power. How can we use this power to build good experiences for our users, to have a manageable app, a maintainable state as we move forward as developers? So the first thing we want to do is we want to centralize all that data with GraphQL. I'm not going to go deep into the details of GraphQL because everybody here has done an excellent job of doing that so far over these last couple of days. Then the next thing that you want to do is serve only optimized static assets. That lets us get away from some of these problems, the jank, the flash of unstyled content, all that good stuff. So why should we centralize our data? The key benefits for me, at least when I was working at IBM and trying to introduce this concept, was we wanted better explorability. We wanted a single source of truth. We wanted to know that the API was the way that it was. You could go and look at it somewhere and make a call about whether or not the thing you needed actually existed. It's more scalable and team-friendly. When you have a GraphQL API that a front-end developer can go and explore without having to email somebody or get in Slack and ask how it works or try to find a Swagger doc and then determine whether or not that doc is up to date, all of those things slow people down, and they drag people's motivation. And that ultimately leads to longer iteration times. It leads to frustrated and demotivated teams. And at the end of the day, a worse experience for your customers because things are taking longer to get to them. You're not fixing problems and introducing new features at the speed that would make their lives better. And ultimately, you end up with a consistent shareable dev flow. Because if everything's coming through GraphQL, the tools you build expect GraphQL. And GraphQL is designed in such a way that you don't need complex workflows to handle the results of different REST API queries. You always get data loading error. You always get an error.message if there's a problem. You have these, now you've got these conventions, these consistencies that you can use to wrap all of these data layers that give you the ability to have predictable UIs, which means that you can make shareable and consistent UI libraries that allow you to do incredible things. The second part of my argument is that you should go static for everything. And the first benefit here is just blazing fast performance. If you're going to stand up all things considered, a static file is going to beat a server-rendered file every time if all other performance optimizations are made. And if your server is beating a static file, it's because your server has been cached so that it's serving a static file, right? So that's always going to be a performance gain. You also get a simpler deployment flow. When you are serving static files, all you have to do is generate the static files and put them somewhere. You don't need these complex CI/CD workflows. You don't need these really in-depth DevOps things. You get a lot of reduced DevOps overhead. So you don't need a load balancer. You don't need to auto-scale containers. You don't need to worry about global availability. You just put it on a CDN and you forget about it. Not to mention, instead of having to pay for all of that infrastructure, instead of spinning up bare metal servers to handle a Black Friday launch, put the whole thing on CloudFront and forget about it. It just goes away. And so let me talk a little bit about how this works in Gatsby. The way that we handle this problem is we expose Node APIs that allow you to create this content mesh. You can take data from any backend, a REST API, another GraphQL data source. You can pull in Excel sheets. You can pull in JSON files. You can even use GraphQL on the file system and pull in things like your images or markdown files. Then we early bind that data at build time so that you, as a developer, don't need to worry about data access in production. It's all bound at the build time, okay? That generates static assets. Those static assets are heavily performance tuned. Under the hood, we do code splitting. We optimize for the purple pattern. We do prefetching. We optimize assets. We generate source sets. We do lazy loading, all sorts of things, so that you don't have to think about performance. It just happens the way that you want it to happen. And then we make it really simple to deploy to somewhere like Netlify or to S3. Whatever you want to use as your CDN, you just dump the artifact that's generated by Gatsby into your CDN, and your site is live. Those changes are made. Our goal here, and then there's a whole other step. Once that gets to the browser, we rehydrate it into a React app, right? So you're not giving up anything by doing this. You're building a React app. We're turning that into static files that you can then serve at the edge in your CDN. And then once it gets to your client, it rehydrates into a React app. So you don't sacrifice any of the power of React in the apps that you're serving. Our goal here is to make the right thing the easy thing. Our intention whenever we do anything in Gatsby is to try to think about this as what is the laziest, shortcuttiest, under-the-gunniest decision that somebody could make while they're using this tool? And how can we make sure that the defaults are in place so that when somebody takes that shortcut or when somebody doesn't look at the config, somebody just opens it and ships it, they get an excellent end result. The user experience is fantastic for the person who's using it, right? We want those defaults in place. We want to take a whole class of problems off your plate so that you can think about building apps, not about tuning apps or shipping apps. Just build it, commit it to GitHub, and forget it. It's going to go live, and it's going to be fast. And so at this point, I imagine a lot of people are thinking in their heads like, oh, well, my app has dynamic data, so I can't do early binding. I can't do this at build time. I need dynamic apps, so Gatsby's not for me. And at this point is where I remind you that static assets are not static apps. Okay? A JavaScript file is a static asset, but you can do a lot of dynamic things with it. So React apps are dynamic, right? I don't think anybody would argue with that. Gatsby is shipping React apps to the browser. So something, 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 transitive property. Gatsby apps are dynamic, right? So let's look a little bit at how this actually works. Let's use we'll do some visualization. So in Gatsby, we start with content from wherever you want to grab it from. And we put all that into Gatsby through our content mesh APIs. Then your workflow is to start building things with React and GraphQL in your just regular React components the way that you would anywhere. Once you're done, we generate static assets that you can then deploy to your preferred CDN. So you can put it in an S3 bucket and use CloudFront. You can just deploy it straight to Netlify, whatever you prefer. Once that's done, it goes to the browser, and it becomes a React app again, okay? But then what happens? How do we get that dynamic step into our code? That's where Apollo comes in, right? Gatsby and Apollo are completely compatible. And so let's take a look at a store, or an example. This is our swag store. Gatsby has a program where anybody who contributes to the Gatsby core is able to receive one free item of swag from our store. You get a PR merged, we'll send you a discount code, we'll invite you to join our organization as a maintainer, and you can claim that for a t-shirt, some socks, a hat, whatever you're feeling. And the way that this works under the hood is that at build time, we pull in Shopify product information. So we early bind all of this. We get these images optimized so that they load super fast. We pull in the product data so that it's server-side rendered and SEO available. And then, on the client side, We use Auth0 to do user management, and we use the Shopify Buy SDK to manage adding and removing items from the cart and actually going to a checkout that's managed by Shopify. On the dashboard side, we show people how many contributions they've made. We show them their most recent contribution, and then down here, we show them some issues that we'd love to get their help with, right? And the way that we manage that is by making async calls to GitHub. And now we whitelist, or we mark this section of the app as client only, which means that Gatsby doesn't try to server-side render it. And that gives us the ability to make literally anything we want in here. We can drop a whole new set of routers. You could drop an existing React app onto this page, and it would just work the way that you expect. So I tweeted a little while ago all the code that it takes to build a Gatsby site using Apollo in the browser. But rather than just show you those screenshots, I figured it would be fun to try and build this. And so bear with me, because we're about to start live coding. Let me get rid of these. And OK, so what we're going to do here is we're going to take this Gatsby site. Right now, what this Gatsby site does is it prints hello world. I added some general styles so that we can see how that works. And what we need to do is add a GraphQL backend to it. Then we're going to get that building. After that, we're going to add Apollo and get some client-side data. And we're going to do that all in the same component. We're going to do it all in this index.js. So all of these files are empty right now. I just put notes in here so that you didn't have to see me look up where these APIs are. And we're going to start with configuring our Gatsby site. And the way that we do that is we export an object, and in it, we include an array of plugins. So the only plugin we're going to use in this example is the Gatsby source GraphQL. And this was built by Mikhail Novikov, who you may remember from schema stitching in GraphQL. And in this, we're going to put in a type name, which we're going to call RMAPI. And we're going to put in a field name. This is what we're actually going to query against. And this is how we namespace to avoid collisions. And finally, we're going to put in the URL. I shot myself in the foot with this earlier, so I'm going to be really careful about remembering whether it's URL or URI. And with that, we're done. So let's run Gatsby develop. And if the demo gods are kind, what will happen is we will get our site running at localhost 8000 and our graphical interface running at _GraphQL. So let's start in GraphQL. And what we can see in here is we've got in our docs, let's make that a little bigger. We've got things that are kind of internal to Gatsby. We generate our sites and the plugins that are available, things like that. But then down here, we've stitched in the Rick and Morty API. So we can look at the Rick and Morty API and see that we've got characters, and that's going to return things like the name, species, so on and so forth. For this particular example, let's just grab the name and image of one of our characters. And so we're going to grab the name and image of Rick. OK, so we run that, we get some data, and now we've got data. So let's put that into our site. So I'm going to jump in, and let's go right into our page. And in order to do this, I need to import GraphQL from Gatsby. And we have a special way of handling build time GraphQL queries, which is why we export our own GraphQL tag template literal. And we're going to export a constant. You can name it whatever you want. I'm going to name it Gatsby query to make things clear. And we do a GraphQL. In here, I'm going to, let's paste this. And what this means is now when Gatsby runs, it's going to run this GraphQL query and pass it in as a data prop, right? Since this is a demo, I'm going to take some shortcuts. So I'm going to just destructure this so that I can get to the data that I need. And I'm also going to grab out this character's name. And let's start there. Let me restart the server because we just added a GraphQL query.
And once this starts, I can go back to here. Let's reload the site. And we end up with Rick Sanchez with a $sign because I did very silly things here. There we go. Next, let's add in the character image. So we'll do a character image. We're going to do an alt tag because accessibility matters. We'll do the character.name. And just to make sure that this doesn't blow out our size, let's do a style tag. Switch back over, and we get our image, right? So this takes very little effort. It's very fast to get going. But now we want to add some dynamic data. So how are we going to do that? Let's add this by creating an Apollo client. And the Apollo client that we want to create is going to start by importing the Apollo client. And I pre-installed all of the packages on this so that, wow, OK. Pre-installed all the packages so that we didn't have to watch npm run. So I'm going to run this from Apollo Boost. And I'm also, because we're going to run this in SSR mode, server-side rendering, we're going to import our own fetch from isomorphic fetch. And that allows the fetch to run not only in the browser, but also in Node. Once we've got those two pieces, I'm going to do export const client equals new Apollo client. I'm going to put in the URI this time. And let's add fetch. OK. So now we've got a client. But one of the things that's interesting about Gatsby is that Gatsby, we have opinions about the way that things run. So we provide a router. And that router takes the components that are in the pages directory and uses them as individually addressable routes. So we can't just use the Apollo provider around our page, or we'd end up unmounting and remounting the provider every time that we move. That's not a good idea. But Gatsby does have the ability to handle a wrap root element API call in both the browser and the server-side rendering mode. So the way that we're going to manage that is we're going to import React. We're going to import the Apollo provider from React Apollo. We are going to import the client that we just created. And then we're going to export a constant called wrap root element, which is the API that Gatsby uses to manage that. And that receives our root element as one of its props. And down here, we just add our provider. And we're going to wrap that around the root element. So at this point, we've defined it, but we haven't actually used it. We need to go into Gatsby Browser and Gatsby SSR to export it. So we're just going to export wrap root element from source Apollo wrap root element. And I'm going to literally copy paste this into the SSR as well. And so what this gives us is now when Gatsby restarts, it's going to wrap the entire Gatsby app in an Apollo provider. And that's not going to give us problems when we run. So let's stop and start. And once it gets rebuilt, OK, everything built without error. Our app loads without error, but nothing's happening yet. So let's add an actual query. And what we're going to do is go back into our page index. We're going to import the query from React Apollo. And we're also going to import GQL from GraphQL tag. And then down here, we're going to define our query. So the API that I pulled in is the same dog API that you've seen in a lot of Apollo demos. I'm not going to go through the graphical part of this. I'm just going to put the query straight in. So we do GQL. And remember, this is a client-side query. And the Gatsby query is a server-side query, or a build time query, which means that they're using different GraphQL tags. So in here, we're going to pull in our dog. And I feel like Rick is a Bichon Frise kind of guy. So let's get the breed. And then I'm going to alias the display image as source. And what I meant by export was const. OK, everybody with me so far? Now we can come in here. We can create a query. We're going to make the query the Apollo query. Oh my God, here we go, nervous fingers. And inside, we get our render prop. We're going to pull out data, loading, and error. We're going to do the kind of shortcut thing of saying if we're loading, let's show a span that says loading. If we have an error, let's return the actual error message. And I can spell it. And down here, what I'm going to do is, assuming we're not loading or having an error, I can return an image with the source of data dog source because I aliased it. And I can do an alt of data dog breed. And again, I'm going to set a style just to constrain the width. OK, so everybody hold your breath. We're going to give this a shot. And so that's it. In about 10 minutes, we were able to build a completely dynamic app using GraphQL on the back end, GraphQL on the front end. And what that means is, ooh, buddy, zoom out a little bit. You can try this yourself right now. Go to gatsbyjs.org. We've got a quick start. We've got a tutorial if you're really new to Gatsby or to React or GraphQL. And remember, you should be using GraphQL for everything. You should be serving static, your entire app is static assets. Please start doing that right now. Please find me for questions if you want to give that a shot. And thank you very, very much for having me.